Hello everyone. In today's video we are going to be attempting the MAT 2016 paper. This is on the PMT website, Physics and Maths Tutor. You can see I've got the questions here before us. So question 1A anyway. Just going to be doing the first few today, but question A is a sequence as first term A1 equals 1. So the first term is 1. And subsequent terms defined by an plus 1 equals LAN. So we have a common ratio of L, so each term is being multiplied by L, and a to the n is obviously the term, isn't it? Yeah. So then 4n is greater than or equal to 1. What is the product of the first 15 terms of the sequence? Alright, well I'll just move this up here real quick. I'll see if I can figure this out. So the first term, so let's just write A. The first term is equal to 1. So LA1 is equal to, so AN plus 1. So A2 equals LA1, which is equal to L. Then A3 is going to be LA2, which is equal to L squared. And then A4 is equal to LA3, which is equal to L cubed. Okay. Now, our first term is 1. So, our first term is 1. So if we're adding up to the first 15 terms, it's going to go 1 plus L squared plus L to the 3, all the way up to L to the n minus 1, isn't it? So it could be L to the 14, because that's the third term, that's the fourth term. So yeah, the 15th term would be L to the 14. Now adding all those up, well, just looking at our answers here, let me get those. We can see that it's not going to be that. That's far too complicated for something like that. It's not just going to be L to the 14, that's the final term. It's not 15 plus L to the 14, because they're all L except the first term, which is 1. So these two are gone. That one's just not going to be it. 15 plus L to the 105, once again, can't get a 15, so I think it's D. Alright, so that's the first one, D. Alright. Now the second one, 1B, is this here. You have an irregular hexagon with all sides of equal length is placed inside a square of side length 1, as shown below, not to scale. What is the length of one of the hexagon sides? So this shape here is our hexagon. You got one side there, that's one side. One side, one side, one side, one side. Alright. Well, I think the way I'm going to figure this out is we're going to draw that square to start off with, obviously. There's a picture associated with it, or it's a graph. It's always a wise idea to draw something. Alright. So we know that this square is of side length 1. Okay. Now let's label, we know this is a side of the hexagon, so we'll label that X. So the sides of the hexagon are going to be X. Alright. So this full thing's 1. Right. This is another side of the hexagon, so that's X. That's X. And then you have X, X. So then since this full thing here is 1, and this little bit is X, that's going to be 1 minus X. Okay. And now we have a little triangle in there where we can get, using Pythagorean theorem, 1 minus X squared plus 1 minus X squared equals X squared. because obviously a plus b equals c. So now we're going to get 1 minus 2x plus x squared. You know, that's going to be times by 2 because we have another one here, is equal to x squared. So then you have 2x squared minus 4x plus 2 equals x squared. So you get x squared minus 4x plus 2 equals 0. Okay, now how do we solve this then? Alright, so it times to make 2, times to make 2, add to make minus 4. I don't think that's going to be a very nice number to work with. We'll complete the squared and see what happens. X minus 2 squared minus 4 plus 2 equals 0. So x minus 2 squared minus 2 equals 0. Okay. So x minus 2 squared either equals 2 yeah, x minus 2 squared equals 2. So if we square root both sides, x minus 2 equals root 2. X equals root 2 plus 2. Which is, if we look on here, you have e is 2 plus root 2, which is obviously the same thing. So I think our answer here is going to be e. So yeah, we'll just put big circle E there. I'll just flip this around, get a fresh page, and we'll go on to question C. Alright, question C. Let's see what that is. Let's see. Alright. The origin lies inside the circle with equation x squared plus ax plus y squared plus by equals c, precisely when c, okay, so we've got to find, basically what this wants to know is when is the origin, when is the distance from the centre of this circle to the origin less than the radius of the circle, because then it will obviously lie inside the circle. If it is less than the radius, it lies inside the circle. So we need to find the distance to the origin from the centre of that circle. So the way we're going to find the centre of that is obviously we're going to use circle equation. We're going to have x plus a squared plus y plus b squared, and then obviously completing the square, we're going to need to minus those squared. So minus a squared minus b squared equals c. Alright. Make sure you can see that, sorry about that. Yeah. So you have minus a squared minus b squared equals c. So our radius of this circle is going to be a squared plus b squared plus c. Obviously if we move those over to there, add them to both sides. So now that's our radius, and we need to find the distance to the centre of from the centre of the circle to the origin. Now the centre is going to be minus a minus b, so obviously you make those negative and that's your centre. So now the distance to the origin is going to be 0 minus a squared plus 0 minus b squared, square root that, that's our distance, which is equal to the square root of a squared plus b squared. Okay, so that's our distance. Now, if we say, so the radius, this must be less than the radius. So we say the square root of a squared plus b. Oh, that's not the radius. Okay, this is the radius. We got to square root that, obviously. If we add those to both sides, you get c plus a squared plus b squared. So you square root whatever's over here to get the radius. So now that is our radius. Okay, so a squared plus b squared square rooted is less than the square root of a squared plus b squared plus c. So now we square both sides. a squared plus b squared is less than a squared plus b squared plus c. And obviously you see that c is greater than 0, which is one of the answers. Yeah, A, C is greater than 0. So that is our answer right there. So we'll put A. Okay. And now we'll do one more. We'll look at D. So if I look at D here, let me get that for you. You have D. How many solutions does cos to the nx plus cos to the 2nx equals 0 have in the range of 0 to 360 degrees for an integer n is greater than or equal to 1? Okay, so what we're going to do first is I think we're going to factorise this. So you have cos to the n of x times 1 plus cos to the n of x equals 0. Okay, so now we know that cos to the n of x either equals 0 or cos to the n of x equals minus 1. So how many solutions does it have? Well, we'll just substitute values into n here. So you have cos x, so this is n equals 1, 1 plus cos x equals 0. So then in this scenario here, either cos x equals 0 or cos x equals minus 1 in order to make this equal to 0. So now for this one here, when does cos equal 0? Well, cos equals 0 at 90 degrees and 270 degrees. So that is two solutions. And cos x equals minus 1 at, let me think, 180 degrees. So that's one solution. So when n is odd, we have 3 solutions. Okay, now if we look at our question here, we can narrow this down. So it says it has one solution for all n for n. It's obviously not that because we've just found 3. 2 for all n, not that because we just found 3. 3 for all n, it could be. And then 2 for even n and 3 for odd n, we don't know yet. 3 for even n and 2 for odd n. Well, we just used an odd n and we got 3. So it can't be E because it's saying there's 2 for odd ones, but we've just found 3. So it's either C or D. Now if we find a solution, or if we use an n and we get that there's, not 3 solutions, then it's obviously D. So we'll do that right now. We'll put in, say, 2. So n equals 2. You're going to have cos squared x times 1 plus cos squared x equals 0. So now cos squared x equals 0. Alright, so obviously we're going to have 2 solutions again because that's the same as cos x equals 0. If you square root 0, you just get 0. So that's 2. And then you end up with cos squared x equals minus 1. So that's an imaginary number because cos x would equal root negative 1. Obviously you can't do that. You can't square root that negative. So it has no real solutions there. So it has 2 solutions when n is even. It says C was 3 solutions for all n, no matter what they are. And we'll pull that back over here. So it can't be that. The only one left is D, which says 2 for even n, which we did just find. We made n even and we got 2 solutions. 3 for odd n, we made n odd and we got 3 solutions. So it's obviously D. So that is our answer there. You have D. Bada bing, bada boom. Those are the first 4 questions. Now, if you liked those explanations, you think they were helpful, then please do show a little support, like and subscribe if you want to. If not, then just leave a comment saying you would like more of this content and I'll gladly make it if this is helpful. But we can go through the rest of the paper if you guys just ask, like, fairly like this one here. This one's alright too. You know, and then beyond H, I've not seen much. Seen a little, but I'll figure them out. But yeah, that was the first few questions of the maths admission test for 2016. You can find this on PMT, Physics and Maths Tutor, if you want to go yourself, or if you want to do the rest of them. And obviously you can confirm my answers by looking at the mark scheme for this too. But this was essentially my overview of it and my attempt. But thank you for watching. Hope you had a Merry Christmas, and I'll see you all later.